All right, everyone. Welcome back from the break. It is just about 6:55 p.m. Central Time. We are going to get started on session 1. And we're going to start right from the very beginning. All right, so I'm recording. I'll also start kind of like a note pad here in one of the replets as I walk through these things. I will share all of that with you. And in fact, with that, let me also do this here real quick. Oops. Let's. All right, so I'm going to drop this into the chat. So that is the folder on my drive. That's the PDF with all of the Code Platoon challenges, which were also emailed out, but then also a copy of the PDF of the slides that I'm presenting. So you'll have access to that. I'll also, real quick here, or actually after class, I'll drop them into Slack. And then with that, this up here real quick. So in Intro to Coding, we scroll back here a little bit and you can still see my screen, correct? Cool. Yeah, last time I thought this was back in October. So each night after class, I will come in and drop a something that looks like this. Like this is session 8 from last year. So I will have a link to the video on YouTube, any of the challenges that we did, and then also like if I have notes, I'll have a link to the notes for the replit. So you'll have access to all of that. And I'll drop that into the Slack either the night of, or depending on how long it takes for YouTube to process the video, I may do it the next morning when I start my day job, just because it does get pretty late sometimes and that video can take like a half hour, 45 minutes to process. All right. So there's a little housekeeping. Everyone should have access to the slides. Everyone should have access to all the challenges that we're going to deal with. And then at the end of class or the next morning, I'll make sure that you get access to any notes that I take and then any of the challenges that we did and the solutions that we worked through together. All right. So what is a programming language? Let us write lines of code, or lets us write lines of code to give the computer a set of instructions to perform to produce some kind of output. All right, so output can be text to the screen, creation of a file, printing something, a fax, an HTTP request, anything along those lines is output. So the computer will only perform exactly the instructions you have given it to perform. That is the hard part about software development. Computers can't guess at what you're thinking. They're extremely literal and they're going to do exactly what you tell them to do. All right, so first things first, values. So every value is a piece of data or data type, and that data type determines how that value behaves. Some values are numbers, so 86, 2021. Some values are text, or what we refer to as a string. So get used to that term, string. So anything in quotes is going to be a string. Some values are functions, and the list goes on. All right. And that is just the most basic definition there. We don't do a whole lot, or actually I shouldn't say that. So the next step is variables. Variables are named labels and identifiers for storing values. So most of the time when you see a value, we'll be storing it in something because when we write software, you can calculate a value, but if you then do not turn around and return it as output or assign it basically save it as a variable or assign it to a variable, that information is just gone. once the next line of code executes, that information goes away and you don't have access to it anymore. So we use variables to basically store values. Remember from math class, like variables X and Y, then like X would equal 7 or 13, something along those lines. Same concept. However, I will say, when they used to write software by punching holes in punch cards, and if you screwed something up, it would take hours to figure out that you screwed something up. And then there was very limited processing power. Then it may be common to say like, let X equal 7. We want to stay away from one letter variables. We want to have descriptive variables that help tell the story while we're writing our code, right? Because if I take a variable and say ham sandwich, and then say ham sandwich is equal to November 13th, that doesn't help anyone out, right? So that variable would be better off as saved date, or like target date, something along those lines that help tell the story about the value that we expect to be there. So var, and if anyone's looked at any of the JavaScript tutorials out there on the web, you probably still see this all over the place. This is the old way of doing things. We don't really do this anymore, right? It still works. It still works in modern JavaScript. But if we were working on a project and you were my junior developer and I was a senior developer and you sent me your code and there was var in it, I would tell you to take the var out and figure out if it needs to be a let or a const. All right, and so similar to const, the let variable can be reassigned but not redeclared, and const cannot be reassigned and not accessible before they appear within the code. So var, let, and const are reserved keywords in JavaScript. You can't use them for anything other than declaring variables. Sorry, let me just put my phone on mute here real quick. All right. So, and let's go ahead and open up a Replit notepad here. So I'm going to create a REPL. We're going to use Node.js. So Node.js is basically JavaScript, and we'll call it session Feb 24 session 1 notes, and we'll create that REPL. All right. So this is a Replit. And we can start declaring variables. We can start writing code in here, right? So we'll say var name equals Charles. All right. So I use var. I gave my variable a name, and then I assigned it the value Charles. It's in quotes, so it doesn't matter if it's single quotes or double quotes. That is a string. Right, so anything in between quotes is going to be a string. And if I hit the run button, nothing happens. All right, because I haven't told it to do anything. I've just told it to save the value Charles under the variable name. Right, so if I want to do something like this, so console.log, right, prints to standard out with new line, multiple arguments can be passed. All right, so I can write Charles in here. When I hit run, I see Charles. But notice this is called hard coding. So no matter what I do, I'm always going to see Charles here. So if I change this to Charlie, these two things are not related to each other, right? I still am just console.logging the string Charles out to my console, right? So this is my console. This is index.js. This is my file. Now, if I want to see Charlie over there, or whatever else I assign to this variable, I actually need to console.log the variable, and I'll refer to it by name, right? And so var name, and we'll run it, and now we see Charlie, right? And if I say turn that to Chuck, and I run it again, now I see Chuck over here, right? So there's my first variable, and there is the value assigned to it. All right, and so when we look at this here, right, let const var are keywords that let you initially declare a named variable, right? So let and then current year. is the name of the variable, and then 2021 is the value that is assigned to. All right, so if I come back over here, if I do this and I change this from var to let, and I hit run, I still see Chuck over here, right? So I've still got the same thing, still works. Let is less restrictive. It typically, like if you see var, you can always replace it with let. Depending on your situation, you may be able to replace it with const, and I'll show you why. So this is actually shorthand for two different steps. All right. So what this actually is this. So it's let name and then name equals Charles. All right. So that's two different things that we're doing there. And if we run this, we still see Charles. What JavaScript allows us to do is, because this is extremely common, is take this and do it both of those actions, which is declaring a variable and then assigning it a value and doing it on one line. Right. And so actually, I'll do this. All right. So for anyone on a Mac that you can use command / so the one right underneath the question mark. On a PC, I believe it will be control and then / again, right underneath that question mark on your keyboard. And that allows you to comment things out. Right. So when I do this and it turns green, it's basically, it's going to tell me, like, it's saying that this doesn't get read anymore. This shouldn't have worked. I don't know why I did. There we go. So name is not defined, right? We'll make this more explicit. We'll call this first name. Right. So first name is not defined. So there is our very first error message. And that's because I've got this commented out and it's not finding it. So we're getting down here and it's saying print the value of first name to the console. It's commented out. So this gets read as plain English. Like I can write anything I want to here. Nothing's ever going to happen. All right. So, and that is, if you have a line, or if your cursor is on a line and you hit that command or control / that comments things in and out. You can also highlight multiple lines and comment them in and out at the same time. And then you can also, if you just type in those two / manually, you can put it in wherever you want to, right? So we can say, declare a variable and assign a value to the variable. And so we'll come down here and we'll say, let full name equal Charles Kubiak. And with this, we are declaring and assigning in the same line. Right? This is most common. All right, so this is normally what you'll see. So when you do this, this is what you would expect to see, right? And so if I change this from first name to full name, and I run it, right, I get my full name over there, Charles Kubiak. Now, let's see here. I'm going to grab Kevin's name, right? So I can say full name equals Kevin Garrett. All right, and with 2 T's. And so I've declared my variable, I've assigned it a value. Down here, I'm reassigning it a value. So now when I hit run, I get Kevin Garrett, right? So because code reads from top to bottom, left to right. So I come in, I declare my variable here on line 2, I assign the value to this variable. I declare and assign the value to this variable on line 4. On line 6, I'm reassigning the value, and I'm then console.logging the full name, which is now Kevin. If I take this and I also console.log on line 6, I'll see both our names, right? So I assign the value, I console.log, I reassign the value, and I console.log. So I see both the names. All right, so code reads from top to bottom, left to right. Okay, and now this is all okay with a let. So if I say const, and I'll say favorite cat, and we'll say Todd. That's I've got 4 cats, and Todd is my 16-year-old. And then I want to reassign the value. So when I say favorite cat is equal to Mo, who's my second oldest cat. And I come down here and I want to see favorite cat. I'm getting an error, right? And let's actually read the error message here a little bit, right? So when you get an error message and you are going to get, as a software developer, a big part of your job is deciphering error messages. You will always, from the day you start coding to the day you stop coding, you will always have far more error messages than you will ever have working code. And so getting used to reading these is hugely important to your development. All right, so with that, this is telling me, and because I've only got one file here, like there's only the one file for me to work in, but let's say I was in a project that had 2,000 or 3,000 files in it, and I'm running a test suite of 1,500 tests, and one of them blows up because I broke it with my new code. This would be very helpful to let me know that this is the file that it happened in. Then it's even going as far as to tell me that it happened on line 14. All right, and so here's line 14, and it's saying type error, assignment to constant variable, right? And so when we come back here, and we look at this, cannot be reassigned and not accessible before it appears within the code, right? So this is reassignment of the value. And I can do that with a let, I cannot do that with a const, right? It is a constant value. And so right here, this is telling me, hey, you can't do that. And if I get rid of this, I'll leave that here. I will say this as a grab this, and then we'll paste that there. Right, so a type error assignment to constant variable, right? So if I hit run again, now everything works, right? So we've got the console.log up here, so we're still seeing my name, and we've got the console.log down here, so we see my favorite cat, Todd. All right. So that is the difference between let and const. Const are more restrictive. You want to use them where possible, because you always want your code to be as restrictive as possible because it cuts down on accidents. But while you're learning and when you're going through the application process, all that stuff, I would recommend just using the let and not necessarily worrying about this yet, because you're not going to get marked down any points in any of the application or anything like that if you use a let, where maybe a const would have been more appropriate. All right. And so we've covered that. And so outputting a variable's value. Outputting a variable's value. The console.log method, we can pass it one or more pieces of data, and it will display it into the console. It returns undefined. Okay. And so with a console.log, this, and we get a lot of questions around this. This question is probably like the #1 most common question. So in the recorded version of this class, what are functions lecture video, I can't get the values of first name and last name to fill with the parameters, right? And well, actually that one's a little bit different, but he's also running into the same problem. But this one up here, working into the code, same page, I console.logged it, just see what I had got the result, but the return value, and I get no result, right? And we take a look at the screenshot, right? So when you return something, returning it doesn't send it to the console, okay? Specifically saying console.log, that is a built-in method. It is the log method on the console class in JavaScript. It's built in for you. that is specifically telling JavaScript, hey, print whatever is in between these parentheses over here in the console. All right. Okay, so any questions on values, variables, anything I've showed you so far? Okay, let's move to data types.
Sorry.
Yes, go ahead.
Sometimes this trips me up. If I don't do a return value, I can still print it out, but that's different than a return value. Like if I want to utilize it to do something with it, right?
Absolutely. And I mean, we get that question asked so much, and I always drop this in here. And we'll definitely be going over this again, so if it doesn't make sense yet, but on that page, I wrote a course update, right? And it explains that console.log is sending it specifically to the console, but you still have to return it. Right, and we're gonna go over the right way so that you're returning from your function correctly. And you can still see things in the console while you're debugging and you're working through the code. And console.log is an invaluable tool while you're learning. And like we use it when we debug production code, like real world code, like we use console.logs, or in Ruby, use something called binding.pry. But all of those things have to be removed from your code before you send it out into the real world, right? And so like when you start writing real projects, like you'll submit your code and you'll have someone review it. And like if you leave a console.log in there, which I do all the time, everyone does, like that's one thing we're always looking for, because if you have real world code, right? Like, so if I go to, we'll say like Amazon.com, right? And let's say I have some sensitive information in here, right, that I'm working on in the back end that like I don't want anyone to see. That could, if I accidentally get that console.log out into production, it could then show up here in your console on your web browser. And so like we don't use, and these are error messages and warnings and like some of the stuff that comes with using React or like a front end framework. But there's no console statements where like I'm actually taking some sensitive data in the code and I'm console.logging and spitting it out so that anyone that opens this panel can see it, right? Like that's not good. And we're always on the lookout for that. So you'll use console.log while you're learning, but you won't use it when you're really writing software. All right, let's see here. So data types, and so the basics. So numbers, 34, 27, it is that. Within JavaScript, it's all numbers, but there are integers, so whole numbers, and then there's floats or floating point, which is anything with a decimal. All right, so we could say let first number equal 87, and we can console.log first number. All right, and we'll hit run over here. Now, I want to point this out. Your browser or your IDE, and again, this is like Replit. I use VS Code, like that's one of the most popular ones out there. I'm working on like a side project. I'm working on a testing application. This is actually Ruby code over here. You see all the different colors, but you see like I've still got comments over here in Ruby instead of the double slash. It's a pound symbol, right? And all of this stuff, like my IDE, like the indentation, like keeping your code lined up. These are all the different colors. These are to help me keep my code as easy to read as possible. Because if, let's just say that all of this was crammed over here to the left and it was all just white on black text, and it's the whole thing, it becomes very difficult to read and very difficult to find where things are at. So all of this is stuff that's done to help it easier to track the code that you're writing. Now, that being said, this isn't quite as colorful because I don't have as many things going on yet, but notice how let, which is a protected word, is blue. And then my variable name is white. And then the value I assign to it is kind of this tan color, right? And then I've got a class, which is white, but that built-in method on that class is yellow, all right? When I write a string, I get this gold color. When I gave it a number, I get this bright neon green, right? And same thing over here, when I print a string out, it's just printing out as white text over here. When I print the number out, I get gold text. Let me actually type something in over here. So, and then, so let's go and run this again. So it's up at the top, right? And so there's that gold and same thing. So this is a number. I can also say let string of number equal 87. All right. And so notice how it's a different color. I've got it in quotes, and I can also console.log it. Right, and see how it's white. So this is telling me it's a number, this is telling me it's a string, right? And it's if you need a number and somehow you ended up with a string of the number and you're not passing the problem, it's trying to help you out. But you need to remember that different data types are going to be different colors over here. All right. And you will run into challenges where this will become an issue. Okay, now strings, double quotes, single quotes, backticks are all strings. These two are the exact same thing. This one is a little bit different. This is called a string literal. All right, and so I can say let cat1 equal Todd, let cat2 equal Mo, and we'll say let cat3 equal Nugget, and then I can console.log cat1, cat2, and cat3, and they'll all spit out right next to each other and should all just run. Oh, it actually gave me some spaces. How nice. So I got Todd, Mo, and Nugget. Right. So they all show up as strings. Now, where it can be a little bit different here, and we'll say we'll do some string concatenation here. So we'll say let hello cat, and we'll say good evening cat1, right? And so now when I do this, I'm going to console.log hello cat. All right. And what I would hope to see is good evening, Todd. How are you doing? And I need a space here and not here. Good evening, Todd. How are you doing? Now, this is a okay way to do this, like when you're solving a challenge and maybe you've got one thing going on. Now, if I told you to write a Mad Lib app where you had to pick 15 different words, like adverbs and all these different things and nouns, verbs, and write that in a paragraph, and then every time you had to do is add a couple of plus signs and keep concatenating this way, it becomes kind of messy and it becomes kind of a pain in the butt. And so we'll say let hello string literal, and we'll use backticks. And so we'll say good evening We'll say cat2. Right, and so now when I run this, good evening, Mo, how are you doing? Right, so I'm actually writing a string literal where I'm referring back to a variable and I'm putting it in line in my string. All right, and then if I needed to change it, I could just change it right here. Right, now it says, good evening, Nugget, how are you doing? So this is what the backticks are for. Is it becomes a string literal, and instead of having to concatenate, which concatenate just means that you're adding two strings to each other or more, it allows you to write your and reference variables in line, right? And that's with $sign and curly braces, and I can keep going up there, right? So good evening, Nugget. How are you doing? This is Kevin Garrett speaking, right? So because I was up here, full name, I reassigned the value, and that's what I'm referencing down here. So again, backtick, string literal, single quotes, and double quotes are the exact same thing. They don't make any difference. All right, and so that's that. All right. So Booleans, so true and false are Boolean values, and they are also protected words inside JavaScript. So let's do this. We'll say, right? So notice how it's white, and then as soon as it gets to false, right, it turns light blue. So again, protected word there. Like you can't just throw true and false around. And we'll go ahead and console.log it. Right? Notice how it's not white. It's not a string. If I do something like this, now it's a string. Now it's white, right? So it's a string of the word false, but without those quotes, it turns like blue, it's false, right? And we'll talk about true and false when we get into control flow and what the computer uses those for. Undefined is a variable that has been declared, but no value has been assigned to it yet. All right, and then null means there is explicitly no value, and null and undefined are different. All right, because remember up here, we declare a value and then we assign it. And so if I were to comment this line out totally, and I say console.log first name, right, I get undefined. And now it's that dark gray there. And that just means that, hey, I saw the variable you're talking about, but no one's done anything with it yet. No value has ever been assigned to it. All right, and if I get rid of that and run it again, I'm back to just Charles. Right? And then when we say, right, notice how null is even a different color blue than false. Run it. So there's null. You get the it's white, but it's that bold, bright white. So null is its own type of value. And let's see here. So any questions on the basics before we jump into arrays? And panic might be setting in right now. I'm moving kind of fast. I'm throwing this stuff out. Don't worry about it. We are going to go over this stuff every night, right? Like we are going to be declaring variables every night. We are going to be working with arrays. We're going to be working with objects. We're gonna be iterating, like, if you see me do something and I explain it and you don't understand it, you can always stop me and ask to explain it again. But have faith that this is not the last you've seen of this stuff. We're going to be going over and over again over the next basically 8 sessions after this. All right, arrays. So is a list-like object that stores values, right? So we've got let tech companies, and you can tell it's an array when you see that square bracket. All right, and what an array does is it holds a list. This is a list of strings. These strings represent the names of famous tech companies. All right, it can be numbers, it can be Boolean values, it can be other arrays, so you can nest an array inside of an array. And array methods have pre-built functions included in JavaScript. We're not going to go through each of these tonight because I believe in session, let's see here. Yeah, in session 3, so on Thursday, we're going to cover all of these built-ins and more. We're going to do like a dedicated example for each one. And I will go ahead and declare an array here. So we'll say let array of students, right? And this is an array. So if I console.log this, and I hit run, I get an empty array right here. All right, now I can start throwing names in here. So I can say Jonathan, Kevin, say, whoops, Deshaun. All right, and so same thing, if I hit run again, there's my entire array. And now notice how these are all strings, but notice how these values are orange, right? And you also see these square brackets over here in the commas. This is, all of these are hints that you're working with an array. All right. And so we'll leave arrays at that for right now. Trust me, we're going to get into much more with those. And then let's see here. So next is objects. Objects are a little bit more complex than arrays. And actually, I apologize. Any questions on what we just talked about with arrays before I move on to objects? And I see a question here about how to open up the console in Replit. So if you've opened up a file, usually console opens up automatically, but if it's not, I believe you can just go to the top 3 buttons at the top right and then do it that way. Were you able to get it, Raven? Cool. So any questions about arrays? All right, let's go ahead and move to objects. So objects are a structure of data that can contain many values using a comma separated key value pairs, right? The big thing here, just like with arrays, we know we're working with an array when we see the square brackets. We're working with an object when we see the curly braces, all right, or the curly brackets. And the other thing that's going to tell us is that we're going to see key value pairs, right? So we're going to see a key, we're going to see a colon, we're going to see a value, we're going to see a comma, and that is going to repeat itself, all right? And so we could do something like this. So we could say let constructor, and we'll just create a empty object here real quick. right? So if I console.log it. Right, so there is my empty object. And so now I can start to fill it out. So I can say first name is Charles. Last name is Kubiak. Say age is 43. Location is Chicago. All right, and well, and we'll go a step past that. We'll say location. We'll make another object here, and we'll say city, Chicago, state, Illinois. All right, and so we can do the same thing with arrays, right? So we can again, these are strings. We can put numbers in here. We can put another array in here, or we can put multiple arrays within this. Right, so there is my object instructor. There is the key of first name, the value of Charles, the key of last name, the value of Kubiak, the key of age, the value of 43, and then the key of location, and then the value is another object. It is a nested object, and inside that object, I have the key of city and the value of Chicago, and the key of state and the value of Illinois or IL. All right, so just like within, I'll comment this out here real quick. Arrays have index positions. And again, all these concepts we're going to go over multiple times. Right, so when I do array of students, I will get the entire array. I'll get Jonathan, Kevin, Deshaun. If I put an index value in here of 1, I just get Kevin. All right, and same thing down here. If I do instructor and I run it, I get the whole object. If I give it a key value, or if I give it a key, it will only give me the value. So if I say instructor first name, I just get back Charles, right? If I just give it location, I just get back the other object, which is the value assigned to the key location, and I get the object with city and state in. And I can keep going. So I can do something like this. If I say city, right, now I'm just down to Chicago. Now, like I said, so we could say let instructor string equal, we'll do backticks. My name is sorry, this won't work. I'm going to do this. That's what I was thinking. Let's see if I made it all the way through that without screwing that up. Nope, let's see here, so index line 65 right here, last name is not defined. So I did instructor, last name. Where's my typo? Age is not defined. How did I screw this up? Do I need to give these? That's why, because I was not giving it the quotes around it to make it a string. I was using box instead of bracket notations. Let me just do this real quick. So another thing with your IDE, so if I were to say open up a blank document here, all right, and say my name is Charles Kubiak, all right, and then I come back here and I highlight Charles Kubiak and I hit the single quote button. Does anyone want to take a stab at what's going to happen? It's just gonna delete Charles Kubiak and replace it with a single quote, right? Like that's what we're used to with Microsoft Word or Google Documents, whatever. When you're inside of an IDE, if you highlight something and let's say I type just a normal character, like I'll type L, it'll replace it. But if you type it with a wrapping character, so curly braces, square braces, parentheses, quotes, single quotes, it'll actually wrap what you have highlighted in those wrapping characters. All right. So you don't have to put one at the beginning and then go to the end of it. You can just highlight what you need, hit the button, and it will wrap it for you automatically. There we go. So hi, my name is Charles Kubiak. I'm 43 years old, and I currently live in Chicago, Illinois. Right. So I used backtick. So I used a string literal to go back, reference all of these different keys inside of my object, and then use that to console.log the values. All right. So that's how we get info out of an object. And a look into the future, almost everything you do as a web developer will be something along this lines. You will be taking JSON data, which is data sent from a backend server to a front end server, and you will be accessing that data and basically making it a pretty format for people to consume on a website, right? And so backend is the server. It talks to the database where all the data is stored. It gathers all the data. It packages it up, sends it to a front end. The front end is what makes everything look pretty and consumable for a front end user. All right. And so you right? So this should look familiar at this point, right? So this is um, a fake API or just like a practice API that sends dummy data so that you can develop against it. So, right, curly braces means it's an object. There's my key user ID. There's the value, which is a number, the number one. ID value is a number, the number one. Title, and then it's a string. It's just nonsense. And then like the body of it. And this is all posts, right? And so this is all being, this is what data looks like when it comes to from the back end to the front end. right? And we see up here that we've got an array, right? We've got the opening square bracket, and then there's the curly braces, the comma, the curly braces, the comma, right? Square bracket, value, comma, right? And same thing here, curly braces, key value, comma, right? So those patterns just repeat themselves. These are the basics, but when I say we're going to be doing it over and over again, this is literally like what I do during my normal day job is figure out how to take ugly data like this and make it presentable to human beings. All right. So moving along here, and any questions before we move from objects? All right. So next is operators. All right. And so we have the assignment operators. So in math, this means equals, right? So like x equals 7, that means that x has the value 7. And with this is a assignment operator, right? So it does not determine equality. So I can't say like console.log 7 equals 7. This should blow up, I think. Right? So invalid left-hand side in the assignment. So it's telling me I have no idea what to do, right? But if I do something like this, and even there, again, colors, the replet's trying to help me out. This one's green, this one's white. That's telling me something's going on. When I put 2 equal signs there, now they're both green, right? And is 7 equal, like actually equal to 7? Yes, it is. That resolves to true, right? If I said the 8, right, I get false because 7 is not equal to 8. All right, but when we have just a single equal, that is the assignment operator. We are taking a value and we are assigning it to a variable. So you'll use this all the time as for assigning a value to a variable, easily confused with comparison operators, double equals or triple equals. Okay, arithmetic operators. So we've got all the ones that you would expect to see: addition, subtraction, multiplication, exponent, division, and the remainder. Sometimes it gets called the modulo or the modulus operator. In JavaScript, it is actually the remainder. But if you say, hey, the modulus or the modulo, like I'll get what you're saying, but it's actually in JavaScript called the remainder, right? So 1 + 1 is equal to 2, 3 - 2 is equal to 1. An asterisk shows shift 8. 5 * 3 is 15 exponents. Some languages may do it where it's the tent, the shift 6. In JavaScript, it is asterisk asterisk. Right, so 3 to the second power, so that would be 9. And then division is just the / underneath the question mark, so 10 / 2 is 5. And then shift 5, so the modulo or the remainder, gives you the remainder, right? So 3 × 3 is 9. That goes into 10 3 times with a remainder of 1 left over. Okay, logic operators, right? So we kind of had a preview of this: equal and strict equal. And again, we go back to, we always want to make our code as restrictive as possible so that we don't get mistakes. All right, because remember up here, right? Remember we had first number and string number, 87 and 87. So if I just take this real quick, counselor comment it all out. And we do console.log first number. Oops, first number double equals string. Right, and so this is equals string of number. Anyone want to take a guess at what I'm going to get here? Is this going to go true or false?
I say true.
False.
It should give me true. Right, and there's my true. So because it is saying that the string representation of 87 and 87, the number are equal. Right, because it is not checking the type of data, it is just checking the value of the data. If I change this to triple equals and it becomes strictly equal, it now is false. Because now it's saying this is a number and this is a string. So I'm checking the value and the type, right? We almost always want to use triple equals, right? And because we want it to be restrictive as possible, so we don't accidentally get a string thrown into a mathematical calculation somewhere that breaks our software. So let me just do this. Uncomment all that stuff, and then we'll do an example down here. All right, so that's equal and strictly equal, and we almost always want to use strictly equal. All right, so greater than and less than, just like in math. And so, and the other thing as well, to be explicit here, is all of these things resolve to either true or false, right? So when I'm checking something, when I'm using a logic operator, it's not going to say 7 is equal to 7. It's going to say this statement is true. It is going to say this statement is false when it actually console.logs, right? So there's true, there's false. When you're debugging things, right? Notice how I'm starting to get more and more output out here. You can always add notes in here, right? So we could say, right? So this is checking this, so that's false, right? So we can put a comment in here, we can write a string in here and separate it from what we're doing by a comma. And a lot of times, like I may just write the line number in here, right? So I could say 75, and this is 71, and that helps me keep track of when I see this, okay, line 75 is false, line 71 is coming back as true, right? And that's just like a little way to help keep an eye on where the stuff is coming from when you're console.log. All right. So let's see here, and it'll be the same for all of these as well. So greater than, less than, greater than or equal to, or less than or equal to. If you were actually writing that freehand, it's like the greater than or less than with just a single line underneath it, but we don't have that on our keyboard. So this is greater than or equal to. And so we can say, let, right, so we get a true there. And if I were to reverse it, right? So now we're saying is 7 less than 6, right? So now it's false. And it's the same thing, is it greater than or equal to, this should still be true, right? And the same thing, if I change this to a 7, right? It's true, but if I get rid of it, is 7 greater than 7, that should give me a false. And it does, because they're actually equal to each other, right? So when you're solving algorithm challenges, you'll be using lots of conditional logic and logic operators. It's very easy to get these messed up, and it should be like one of the first places that you check when your code is not doing exactly what you think it should be. All right, and then lastly are the logical and logical or. So in JavaScript, it's a double ampersand, so shift 7, and the or is what we would call, excuse me, a double pipe, which is the character right above the backslash, which is above the enter key on most keyboards. And so if we were to take a look at something like this, so we can say, let first num equal 8, second num, and we'll just actually call this integer. Right, we can say console.log first int greater than 5 and second, oops, int is greater than 5. And when we do this, should get a false, and we get that false. And let's put this here 85, so keep track of it. Right, so line 85, that's a false. And because what, for this to be true, both of these have to be true. Right, so if I say is it greater than 4 and is a second int greater than 4, right, that's now it's true. But when this was 5, it was equal to 5, and so this was true and this was false, so the whole thing becomes false. So the first part has to be true and the second part has to be true. All right, and if we do why did I just forget how to spell evaluate? Right, and you can keep going, right? Like you can have, in theory, as many ands as you want in here, but each time you add an additional one, your code gets more and more complex and it gets harder to read. So that's always something to think about as well. And then when we do a, let's go ahead, 5 and 5, right? So this would be false because this is true and this is false, so the whole thing is false. Right, so because this is false, the whole thing is false. Because this part is true, it doesn't matter. And I could have 50 more false things, and this would still be true, and the same thing over here, I could be looking at 50 different integers, and 49 of them could be true. If one of them's false, the whole thing resolves to false. Any questions on logical operators or logic operators? All right, it is 8 p.m. Let's go ahead and we'll call it 8:01. So we'll take a 6-minute break here, and we'll get started back up at 8:07. We'll see how much of this we can push through to get towards the end, and whatever we don't finish of section 1 tonight, we'll lead off with on section 2 on Wednesday evening. All right, so I'm gonna go ahead and pause everything, and we'll be back in about 7 minutes. All right, everyone, welcome back from the break. It is 8:16 p.m. Central Time. We're going to cover as much as we can through the end of class here, and whatever is left over, we'll kick off on Wednesday when we start class back up at 6 p.m. All right, so we're going to jump to the next section, which is functions. And functions are reusable blocks of code that perform a specific set of instructions that you defined or that you built into the language. Functions can be defined to accept 0 or more inputs, what we call parameters, and in most cases output a return value. To declare a new function, use the function keyword followed by the name of the function. When a return statement is encountered, the function exits immediately, returning the return value. All right, so here is the skeleton of what a function will look like. All right, so function, right? So just like before where we were doing let, we'll actually call function, and we'll give it a name. We'll say add 2 numbers, right? And then we give it parens. And then we'll give it some parameters, right? So parameter 1, parameter 2. And then we're assigning parameter 1 and parameter 2, or adding those 2 numbers together and assigning it to a value. And then we're returning that value. All right, so we could say, excuse me, we'll leave it empty for right now, and we could do return 5 plus 5. All right, and if I hit run, nothing happens. I'm just going to, for right now, we're going to make it like none of this other stuff exists, right? And when I hit run, I get nothing, because I gave the replit a function. I told it what that function does, but I never activated the function. All right, and to activate a function, you have to call it. All right, and to do that, I would hit add 2 numbers and then give it the parens, right? And right now there's no parameters, it's just returning 5 plus 5. Right, and when I hit run, I still get nothing because my function is returning, but notice how I'm not console.logging, right? So one way to fix this would be to take that, get rid of my return statement, and put console.log up here. All right, now when I run it, I get 10. Now the issue is that I am not returning anything, right? Like I know that these 2 numbers are 10, but 5 plus 5 is 10. So if I do something like this, console.log, add 2 numbers, triple equal to 10, right? This is going to return 10, but when I run it, I get false, right? And it console.log 10 the first time when I called the function here, and then I called it a second time here, and I get false. And the reason being is that when I do not return anything, this is actually undefined, right? So if I just console.log this, just my function with no return in it, it's returning undefined. Okay, and that's why your functions should almost like, there'll be specific instances where you won't have a return, but you'll almost always have a return value. Right, and so what we want to do is if we need to see what our function is returning inside of the console, we'll actually wrap the function call in the console.log, right? So now if I do this, right, there's my number 10 being sent to the console, right? And we'll say line 99. All right, so we know that this is the console.log that's sending, right? The one on line 99. Now, if I do something like this, and I say triplet equals 10, I would hope that this would return true. Right, and it is, because this gets resolved, right? So what the computer is actually seeing is this. Right, so this return 5 plus 5. So instead of just seeing add two numbers, it's actually seeing the number 10 here, seeing the return value. Now, this function, no matter what, is always going to return the hard-coded value 5 plus 5. And this doesn't make this very reusable, right? And so what I want to do is we'll say num1 and num2. And so now I've got parameters, right? So we talked about this over here, right? So I'm declaring my function, I'm naming my function, and then I'm giving it the parameters. And just, you can think of these like a variable, but they're only available inside of the function, all right? And so now if I run this, oops. That yet. We'll say num1 plus num2. Right, and I get not a number because I'm not actually passing anything in here yet. This for right now. And so now I can pass in the numbers 5 and 5. Right, there's my 10. I can do 50 and 25. Now I get 75, right? And now this has become a reusable piece of code. So instead of having to write all of this over and over again, right? And like, this is very simple. I had showed you an example or like some Ruby code that I was looking at or working on for like a side project, right? So same thing here in Ruby, instead of saying function, you say def, and I post my expense, right? And so this actually has 5 lines of code in it. I'm calling this function here. I'm calling this function here. I'm calling it here. Right, so 3 times. So instead of having to have 15 lines of code, I can just have 5 lines of code and reuse it over and over again and give it different variables each time. Right, so the same thing here. This one's a little bit simpler, but now that this is declared, I can use it over and over and over again. Right, so I can say 150 plus 25, I can say 20 plus 25, 30 plus 25, 5 plus 25, right? And I can keep reusing it over and over. 75, 175, 45, 55, and 30. And this is just addition. We could do one for multiplication, subtraction, powers, anything you could think of. We could take some of the code that I did up here, right? Like where I did this, and I could put this inside of a function. And then instead of just referring back to something static, each time I call the function, I could ask for a first name, a last name, and an age. And then it would print that out without having to rewrite the string over and over and over again. All right, so this is our first reusable building block. All right, and so same thing here, like they just called it function name, param1, param2, right? And if we give it 1 and 2, we get 3. Calling or invoking a function to execute the instruction or task, pass in any arguments. So again, you'll hear them called variables, are not really variables, but like if you say, hey, I passed a variable into the function, I'll know what you're talking about. But an argument or a parameter is more common. Right? And so what I would say is focus on writing your function like this. You will start to see it this way, right? And so this is, again, this is the ECMAScript 6 or the what we call ES6, which was like the major revision of JavaScript back in 2015. So going on 9 years ago now, but this is called a fat arrow function, and this is the new way of doing it. All right, but if this confuses you, you can also do an anonymous function. Like, you don't have to get good at writing the function 3 different ways yet. Just pick a way and stick with it, right? And get comfortable doing it that one way, right? Because I can do the same thing here. So I can say, let add 3 numbers equal right? And this should give me 6. And there it is, there's my 6, right? So this is the old way. And this is the new way. I don't care when you're doing it, whichever one you're comfortable with. But don't stress out doing both of them. Just pick one and get comfortable with that one. All right. Any questions on functions? Going once, going twice. All right. Control flow. So conditional logic. So when you want to control how a computer goes through your program, you use control flow. So this is how computers make decisions. All right. So your control flow will either evaluate to true or false. So again, we're back to those Boolean values. It allows us to select a different outcome depending on the user input or the result of a computation. All right. And so we can take a look at something here, and I'm just going to comment this stuff out too. We can say, we'll call it variable my age, and we'll assign it the value an integer of 25. And we can say, if all right. And so when I run this person is old enough to vote, right? Because we're taking my age, which is equal to 25, and we're saying, is 25 greater than 18? All right, and that is true. So this evaluates to true right now. And in an if statement, you don't technically need an else statement, right? So if I run this, I still get this person is old enough to vote, right? If I do this and drop it down to 17, right, I just get nothing. So it skips over, if this is not true, it skips over what's on the true side of it, right? And technically we should say is greater than or equal to 18. Right, and then if we do not hit If this does not evaluate to true, then we take the other path. All right, and so if we turn this back to 17, we get this person is too young to vote. Okay, so this is a if-else statement. These are very common. We can also continue to add additional branches, right? So we could say, greater than or equal to 21. We could say this person is old enough to vote and drink. And then we could say, else if let's see, sorry, that's what I did. I get rid of that. All right, and then finally within the else. Why are you mad at me? Opening, closing, if doing it right, JavaScript, else if. Opening here, that's what it was. All right. So now, when we do this, when we run it, if I give it 17, this person is not old enough to vote or drink. If I give it 18, this person is old enough to vote, but not old enough to drink. And I would get the same thing if I did 20. Oops, sorry. I did not want to change that there. I wanted to change it here. Right, and then if I change it to 40, right, this person is old enough to vote and drink, right? And so depending on how these evaluate, you will go down different paths. And this is how the computer makes different decisions, right? And this is like a very simplistic example, right? So we could say, if person is 18 or older, we could then have another check in there that says and registered to vote, or is a US citizen, right? Like in different things. So we can make this more complicated, but this is the basics of how a computer makes a decision. So we can do just an if statement, an if else, or we can do an if, else if, else. And you can continue to add these, right? So I could bump this down to an else if, and I could put if greater than 25 years old can rent a rental car without paying like a ridiculous surcharge, so on and so forth. Are they old enough? Are they of age of retirement? Right. So we could just keep building out additional conditional statements here to check for different things. Any questions on conditional statements? Right, and here's the skeleton of if, do this, else if, do something else, do something else. All right. Iteration. This is where we're going to start to get we're ratcheting things up, right? So like we did values, and then we did variables, and then we did different data types and how those get assigned to variables. Then we started to talk about like the different logic operators we could do. Then we talked about how do we encapsulate that into something reusable. Iteration, or what's commonly referred to as looping, is how do we get the computer to do a task repeatedly, right, for a specific number of times, right? And so loops can execute a block of code a number of times. As long as the condition is true, the block of code will continue to execute. When the condition becomes false, the code after the end of the loop will be executed. All right. And this is a while loop. And so while this condition is true, repeat the logic. Right. And so we'll go ahead and write this example over there. Let's go ahead and comment this out real quick. So we'll say let A equal 0 while A is less than, we'll call it 50. And then now we want to write our logic, right? So we can do console.log A. And where you get in trouble when you're looping is that, especially in a while loop, I have to move towards my case, right? Like I have to move towards my conditional to move it, to make it false. Otherwise, I am writing an infinite loop and it will never stop. So if I hit the run button, I'm just getting 0 over and over and over again. And they used to show the resources you were consuming over here. I don't see it anymore. But like this is going to keep going until I stop it or the replit runs out of virtual memory. I'll hit the stop button, right? And all this did was just, and you can see my little scroll bar over here, is just kept doing 0 over and over and over because I'm not moving towards flipping this from true to false, right? Now, what I could do is say A is equal to A plus 1, right? And so what that is saying is now A is equal to 0, while A is less than 50, so 0 is less than 50, this is true, console.log the value of A, and then assign the value of A plus 1 to A. So 0 plus 1 is 1, so A is now 1, right? 1 is still less than 50, and we're going to console.log it, and now we should count up to 50 or 49, and then we stop, right? And it's not scrolling any further, but we can say console.log this executes after the loop. All right, so this executes before the loop. There's my loop, console.logging my numbers. I hit my criteria because basically I console.log 49. 49 is plus 1 is 50. A is now 50. 50 is not less than 50. So this is false, it stops, and then we execute the next line of code. All right, and that's how a while loop works. And this is just something very simple, but we can put all sorts of information inside there and have it do all sorts of different things. All right. So there, the same example right there. Now a for loop looks a little bit more complicated, but it does the pretty much the exact same thing. There are certain situations where a while loop will work better than a for loop. Namely, when you're not counting, the while loop is better. So you could do something like, I could write a game of tic-tac-toe and say, while I could say, let wants to play again equals true. And then I could say, wants to play again. And then I could say all the code for my tic-tac-toe game And then at the end of the game, we ask player, do you want to play again? And then the player would then, depending on their actions, basically set wants to play again to either true or false. Right? And so as long as a player keeps saying they want to play another game without having to count to 50 or anything like that, as long as wants to play again is true, we'll keep looping through the game over and over again. But as soon as they respond to the question, I no longer want to play, this gets set to false, the game exits, the program's over. All right, and so that would be a specific use case for a while. A for loop has three things built into the top of it, right? So the initialized variable counter, the run condition, and the increment and decrement counter. All right. And so we can write this exact same thing here, right? In a for loop. So we could say for let I equal 0. Right, so instead of a, we would call it I. So this is the iterator. This is about the only time you can get away with using a one-letter variable. And then how long do we want the loop to go? We can say while I is less than 50. And then what do we want to do? Well, we're just adding it +1. So we can say, we could say I equals I +1. We can also write it in shorthand, and we could just say I++, which would be more common. And then we can say console.log I. Right? And we'll say, we'll add for loop. Right? So exact same thing, start at 0, end at 49. This was in our while loop. This is our for loop. Right? And if I put more code in here, it executes after it loops through everything. Right? So this did the exact same thing as the while loop in this specific situation. We just took this and moved it into the line when we declared the for loop, and we gave it all of this information automatically, right? And so you can see what took us 1, 2, 3 lines of code here, we were able to do on one line of code when we're counting. Right, so same thing as the other one. All right. There are other types of loops. You won't use these as often, and you'll want to learn them, and I'll use them a couple of times in class. But when I can use a for loop or a while loop, I will use those first, because you can do these two types of loops with these two types of loops, versus these ones are very specific. Like a for in loop only works when you're iterating through the keys of an object. And you can also do that with a for loop. And same thing with for of, when you're iterating through the elements of an array, you can accomplish that same thing with a for loop. This is a little bit cleaner, but while you're learning this stuff, instead of trying to remember how 3 different loops work, remember how the for loop works, right? And get good with the for loop. And then once you're really comfortable with when you would use a for loop and a while loop, and you're comfortable with objects and arrays, then you start branching out into for in and for of loops. All right, built-in methods. Let's just take a quick check here. Okay, cool. So we should be able to knock these out tonight. All right, so, and sorry, before that, any questions on iteration and writing loops? Going once, going twice. All right. So Here. Okay, so built-in methods. So we've not covered it yet, and you don't need to know it for this. But there's different levels, and it's different in different languages. But there's different ways that you can organize and encapsulate your code. What we've covered so far is how to write a function, right? So this is a function. This is a function, right? This is the old way of writing it. This is the new way of writing it. And this is how you organize some reusable code. The next step up from that is called a class. And we haven't really dealt with any classes yet, but that is how you keep your functions organized, right? So like when we're writing object-oriented software, which is the vast majority of web development is going to be object-oriented, and I'll talk a little bit about it, but you don't need to know it for this class yet. You will organize similar functions into you'll keep those organized with classes, right? So like if I created a class called calculator, then I could have a function for adding numbers, subtracting numbers, multiplying, dividing, all the different mathematical operators, and I'd keep those organized under a class called calculator. All right. When I just have a function hanging out on its own, it is called a function. When the function belongs to a class, it is called a method, right? And so when we talk about built-in methods, right? So log is a built-in method on console. All right, when we were looking at the definition of array back up here, right? Like length is a built-in method on the array class, pop, push, shift. Objects have built-in methods, strings have built-in methods, the number has built-in methods, and we'll get into all of those. And there's lots of different ways to do it, right? So like I can type in Google JS array.length. All right. And you'll get lots of different stuff out here. Free Code Camp, the Tutorial Point, O'Reilly Media, JavaScript tutorial.net, W3 Schools. This top one, MDN Web Docs. This is the this is the source of truth. All right. This is the Mozilla Developer Network. These are the guys who are basically like they write Firefox. They're helping maintain JavaScript as a language. This is the most up-to-date. This is the most correct information. All right. So when you're looking up how to do something, or like if you're looking up a built-in, I almost always recommend it. When I'm in class, I'll always try and do it through MDN, right? Because they're going to give you the definition of what it is. They'll give you an example that you can run, and then they'll get further in depth with it, and then start to talk about the different things that you can modify it with. All right, and so like this is just array. So the data type array, right? Like the at, concat, copy within, entries every, right? Like there's tons of built-in methods on this. If I type in number, right, and pull this up, these are all the built-in methods on number now. And same thing for string, and the object, all the different things here will have built-in methods with them. All right, so there are common actions that we perform on specific data types, and most languages have built-in methods or functions that allow us to perform these actions, right? So if I call a new state or declare a variable state, assign it the value of Illinois, and then run state.to uppercase, this is a built-in method on string that will send everything to uppercase, right? So dot push, this is on an array. Dot push will add a value to the end of an array. To fixed will get rid of like basically repeating decimals and chop it off. to a fixed decimal point, right? So those are all different examples of built-ins, right? So strings, numbers, arrays, objects. And like I said, we will cover in depth on different nights, like built-in methods for each of these. All right, so it is 8:50. We're at the last section, which is problem solving. And so we're gonna just kind of talk about the general thing here. This is, we talked about at the very beginning that writing software or like programming is hard, and you have to think differently, right? And a great example of that, and a popular example, is making a cup of coffee, right? So if I'm a human being and I want to make a cup of coffee, right? I put the coffee in the machine, I put my cup underneath where the coffee comes out, and I hit the button, right? And that's how I would describe, from human to human, how to make a cup of coffee, right? But if I was programming a Keurig machine, I have to say, is the coffee powered on? Is the lid down, right? Is the water at an appropriate level? Is the water heating? If not, initiate the heating cycle, right? And all these different things, like, is the button pressed? What button was pressed? And so it becomes much more detailed and synchronous when we're writing software, and how we have to think about how we're going to solve a problem when we're writing code. All right, so understand what the problem is asking you to do, how many inputs are required, what data types, what's the expected output, what are the data types of the output. And then also, and when we get into the actual challenges here, and if anyone's kind of looked ahead, I haven't done anything with the bonus challenge, but with these, like all of the normal challenges, I've gone in and added what's called prep. And so before we write any code, we're going to talk about what our prep work is, right? So like, what parameters are needed to solve this problem? What should the return look like when we're done with everything? What's an example of that? And then we have some space to write some pseudocode, which is just basically us kind of talking through the steps that we want our software to take. Now, this one is the first problem, is pretty straightforward. It's not a big deal, but like when we get towards the back of these, like in the, basically they go from easiest to hardest. The hardest one on this list is employee data. And so, but like when there's number of characters, we're using objects and loops. Right, we pop in here, we look at the README, write a function that takes in a string of lowercase characters and returns an object containing the count for each letter in the string. And so this, like, if I gave you a sentence on a piece of paper and I said, tell me how many letters are in each of those sentences, and write it down, right? Like you'd write B and then you'd count them and you'd write it. And so that's how you would do it as a human, but as a computer, how do we tell it to iterate through this string? How do we break this string apart into individual pieces? And then how do we keep track of each of the occurrences of these letters, right? And so this is where the pseudocode comes in, and that we'll start jotting this down step by step, because this is probably 6 or 7 different steps to get a correct answer, right? And so we'll write each of those steps down. All right. This one is like double highlighted, and you're going to hear me say this a lot. Break down the problem into smaller problems. So if I give you something like this, like number of characters, and you're going to need to manipulate a data structure, right? So you've got a string, you're going to have to break it apart into an array or an object or something to hold your different counts, then you're going to have to loop through and iterate through it. Right now, your head's probably exploding with what I just said, but this is why we do the pseudocode is we take our big problem and we break it into 4 or 5 smaller problems, and then we start to solve one problem at a time, right? And then at the end, once we've solved all the problems, we come back and glue it all together and we get our one big solution at the end. All right, and so run your code often. Don't type a bunch of lines of code or try and solve 3 or 4 problems and hit the run button and then the whole thing blows up. Figure out one part of your code, run it, see if it breaks or not, see if it does what you thought it was going to do. If it doesn't, fix that one part. If it does work, then move to the next part, because if you've got 3 or 4 different moving parts and you don't know which one's broken at this point, it's very easy to get into the deep end and start flailing around. And then you end up deleting all of your code and starting back from the beginning. All right, so debugging, we talked about that. We're going to practice that quite a bit. We're looking at the return or the errors that we were getting over here, and it's helped guiding us to where the problem was. And then lastly, you are going to get better at Google than all of your friends, because there is no piece of code in the world that hasn't already been written. We're not here to reinvent the wheel. We're here to find the wheels and attach it to our cart. All right, so it's 8:57. Are there any other questions from me before I hit pause on the recording for the evening? Anything else that wants to be captured for posterity? Going once, going twice. All right, I'm going to pause the recording here.